Hello everyone, my name is Jalen Bryant S. Ong from BSAE 27. This video is a small presentation of the construction of my aircraft model. Also, I will also discuss the basic aircraft components of the aircraft model that I built and the purpose of the following components, which are the fuselage, wings, and empennage. A model aircraft is a small unmanned aircraft and may be a replica of an existing or imaginary aircraft. The sizes of the aircraft model may vary from small to very large, especially when used to research the flight properties of a proposed full-scale aircraft. The aircraft that I base my model on is the Milholland Legal Eagle. The Milholland Legal Eagle is a high-wing strut-brace ultralight aircraft with a single-engine tractor configuration and conventional landing gear from the United States. It got its name because it can be designed in accordance with the United States FAR 103 Ultralight Vehicles Regulations, even when fitted with a 4-stroke engine. The data shown are the specifications of the Milholland Legal Eagle. We will now proceed to the discussion of the basic components of the aircraft, which includes the fuselage, empennage, and wings, along with their purpose and functions. Although airplanes are designed for a variety of purposes, most of them have the same major components. The overall characteristics are largely determined by the original design objectives. There are many parts of an airplane, and each has its own specific purpose. Let's take a look at the main components of the airplane and get a better understanding of their functions. First, the fuselage. The fuselage, with its long hollow tube that serves as the airplane's body, is one of the most important aircraft components. The fuselage structure of the aircraft model I designed is of the truss type or framework type. Many lightweight aircraft do use welded steel tube trusses in this form of construction. Steel or aluminum tubing is used to build the truss-type fuselage. Welding the tubing together into a series of triangular forms known as trusses provides strength and rigidity. So longeron are spar-like structures that run lengthwise of the airplane's fuselage or spanwise of a wing. The purpose they serve is to transfer loads and stresses from the aircraft's skin to the formers. The diagonal and vertical web members are riveted or bolted into one piece with cross-bracing members. Small airplanes generally utilize these web members using aluminum alloy tubing, which are used to reduce the weight of the aircraft. Let us now proceed to the empennage. The empennage is the whole tail unit at the extreme rear of the fuselage, and it provides stability and directional control of the aircraft. In the empennage, the horizontal stabilizer keeps the airplane's nose from moving up and down, or also called the pitch. The vertical stabilizer allows the airplane to weather vane into the relative wind. This helps prevent the side-to-side motion of the aircraft's nose, which is called the yaw. The hinge part on the horizontal stabilizer is the elevator and is one of the primary flight controls. When the pilot in the cockpit pulls back on the yoke, the elevators go up, causing more force to push down on the tail, lifting up the nose of the aircraft. Raising the nose changes the angle of attack on the wings, increasing lift. The rudder, which is the primary control on the trailing edge of the vertical stabilizer, is controlled in the cockpit by the pilot using the left and right pedals. When the pilot pushes the left pedal, the rudder deflects to the left, pushing the tail right and the nose to the yaw left. Using the rudder in combination with the ailerons causes coordinated turns by the aircraft. Now, we will discuss the wings of the aircraft. The wings, also commonly known as foils, are aircraft parts that are imperative for flight. The airflow over the wings is what generates most of the lifting force necessary for flight. There are numerous wing designs, sizes, and shapes used by the various manufacturers. Each fulfills a certain need with respect to the expected performance for the particular aircraft. The wing of an aircraft consists of stringers, wing ribs, fuel tanks, ailerons, and flaps. Stringers run lengthwise along the spanwise of a wing. Their purpose is to serve as structural components that transfer loads and stresses from the aircraft skin to the formers. The wing ribs determine the shape and thickness of the wing or the airfoil. The fuel tanks are either an integral part of the wing structure or consist of flexible containers mounted inside of the wing in most modern aircrafts. Ailerons extend from about the midpoint of each wing toward the tip and move in opposite directions to create aerodynamic forces that causes the airplane to roll. Flaps, like ailerons, are located on the trailing edge of the wing. Unlike ailerons, the flaps move symmetrically on each side and create more lift and drag. Flaps are typically used during takeoff and landing when aircraft speeds are lower to create additional lift and reduce stall speeds.